Good afternoon to one and all present. Uh, present of we are starting the session 3 of K3 of sponsored by UICTE, New Delhi. In this session, we have Dr. Ravi Nair as our guest speaker. Dr. Ravi Nair is a doctor by profession. He is a consultant, otolaryngologist, and head and neck surgeon at Sakra Hospital, Bangalore. He is also a director of Biomedical Innovation Programs, C-Camp, Bangalore. He also has headed as Dean Academics in Dean Center for Academic Research Healthcare Global Enterprises, and also held the post of Head of Department of ENT at St. John's Medical College, Bangalore. He was the chairman of Subcommittee on Research, Indian Academy of Otolaryngology, Head and Neck Surgery. Member of Board of Undergraduate and Postgraduate Studies in Surgery and Allied Sciences at Sri Devaraj Arts Academy of Higher Education and Research, Kolar. He was Association Member, AOI, Indian Society for Head, Eye, Neck Oncology, Foundation of Head, Eye, Neck Oncology, Indian Society of Pathology, Association of Phonosurgeons of India. His clinical experience in India includes that his service was rendered in Biomedical College, Sason Hospital, Pune, PGIMER, Chandigarh, Tata Memorial Hospital, Mumbai, St. John's Medical Hospital and College, Bangalore, and HCG Hospital. Overseas clinical experience include Institute of Gustave Roussy, Paris, Memorial Sloan Kettering, New York, Indianapolis Memorial Hospital, Sultanate of Oman. Sir also holds a AOIE Merck Award for studies on airway resistance at high altitude. Over 60 peer-reviewed publication and book chapters have been authored by him. He is also the editor of Journal of Precision Oncology, Bulletin SCG, Proceedings of Tumor Boards. He is also into an editorial board member of Indian Journal of Otolaryngology. He is also a scientific reviewer of journals such as Indian Journal of Surgical Oncology, American Journal of Nursing, Indian Journal of Otolaryngology. Sir, on behalf of the Department of Biotechnology, the Oxford College of Engineering, the management, the principal, HOD, staffs and students, we deem it a pleasure in having you as our guest speaker for today, sir. So welcome, and the forum is over to you, sir, to start with your session.
Okay, good afternoon, all of y'all. I'm extremely pleased and honored to be part of this academic activity. So let me move straight to my topic, which is biomedical innovations, because that is my passion and something I've been involved with for many years. What I give is my personal perspective, so I do not claim to speak for everybody. Let me clarify, am I audible?
Yes, sir.
Am I audible right now?
Yes, sir. Yes, sir.
Yeah, okay. So I hold the post in the Center for Cellular and Molecular Platforms, C-Camp, which is a governmental or quasi-governmental agency, which has been charged with uh, assuring that funds reach a lot of needy places for biomedical innovations and has tremendous experience over many years in this field. Now, I need to get some concepts very clearly, especially to the student community. An idea is not an innovation. An idea has to be made into a product for it to be considered an innovation. So we have here this photograph of Edison and his phonograph. He may have had the idea of making a phonograph, but until he got it down in bricks and mortars, it cannot be called an innovation. Anybody who deals with IP will tell you the same thing. Just having an idea cannot be made into an IP. So you have an idea and you have a product. Other examples are this young and handsome person called Edwin Land, who had an idea that everybody wants to see a photograph. A child, for instance, wants to see a photograph instantly, and therefore he developed the Polaroid camera. Now, I brought this up because there's an interesting aside that the moment digital cameras came into vogue, Polaroid cameras disappeared. And therefore, that is the next axiom which you must understand, that an innovation, making an innovative idea, does not equal to making a successful idea. That journey is one of entrepreneurship. Now, the example we use is of Henry Ford, who had an idea about an automobile. But what made him succeed, there were many people making automobiles all over the continent and USA. But what made him succeed was this discovery of his that if you use an assembly line, you can make these things very fast. And these are the Model T Fords, which are a legend in the history of automobile engineering because it made cars affordable to everybody. The second axiom, which I like to tell everybody who is dealing with biomedical innovations, is that there is a wrong concept that a doctor is necessarily someone with an MBBS degree. Now, previously, a doctor was somebody who is, as you can see, Sigmund Freud with a cigar in his hand, was a man who was a wise man who would put his hand on your pulse and give you a diagnosis. But early on in this century, we realized that just the man and knowledge is not enough. You require tech. And therefore, you see the images of people with CT scans, MRIs, looking at microscopes, looking at pathology slides, and so on and so forth. So they became more scientists than doctors. And today's philosophy is that anybody involved in healthcare is a doctor in the sense that though not legally authorized to prescribe, is essentially somebody who should have the same level of professionalism, the same level of concern for the patient as you would expect from a doctor. So, who is a doctor? Anybody involved with healthcare, provided he or she shows a professional and compassionate attitude to living beings. And they need not even only be humans, they could be animals. So, this paradigm shift is something which I would like you all to understand, that I do not come here as a doctor speaking to engineers. I am coming here as a fellow professional involved in healthcare. And until you start considering yourself like this, you are crippled because you always have this attitude, so and so is a doctor, so and so is an engineer. We are all colleagues in this battle, otherwise we will all fail collectively. The reason for this is the realization that medical science is not a standalone science. Medical science is an applied science. Now, if you look at it in a slightly different attitude, suspend disbelief and listen to me. All basic sciences are linked. Now, a lot of people who do biology think that the biology science is different from chemistry, and chemistry is different from physics, and physics is different from mathematics. That is something extremely short-sighted. All sciences are linked. If as a biologist you don't know mathematics today, you're doing yourself a disservice. So medical science is largely a science which is an applied science of biology. But medical technology, which is relying on engineering, is an applied science on biology, physics, chemistry, and almost anything you can imagine. So all biology is advanced engineering. And biology, when applied to healing, forms the basis of medical science. To underline this, I would talk about, chemical vats. And if you look at the similarity between chemistry and what goes on in biochemistry in life forms, you would see what I am saying. Anybody who knows pulleys will immediately see muscles and tendons working like pulleys and levers. Anybody who thinks that Edison invented light would have to go back a little to the to biology, and when you see cold light in life forms, you will realize that nature was there before you. Civil engineering too has many parallels. If you were to think that we build tall structures, you should see an ant hill. Compared to the size of the ant hill is far bigger than any man-made structure. Compared to the complexity of the bird's nest which was made in China for the Olympics, the weaver bird's nests are far more complex. Anybody who's interested in aeronautical engineering would immediately see the similarities between our feathered friends and our fixed wing flights. Whether it is in the use of short wings for speed, long wings for gliding, or whether it is in the use of propulsion techniques, or whether it is in the use of thermals to reduce effort when flying. Even computers borrow a lot from the human brain. The human brain is a master of parallel processing and networking, and computers have progressed far beyond what they did at the beginning and are coming closer and closer to human brain neural networks. To the extent that you now have the science of biomedical interface engineering, whether it is the image which I'm showing here of a neuron being attached to an electrode, or a hand which will be attached to a patient's amputated arm. Now, I always have this problem playing this video. I'll see at the end if I can play it. I will play it because usually when I try it fails. I'll just give it one try. If it works, you're lucky. Okay, so I pass it. I'll come back to it later when I go off screen. Now, my journey in this aspect, I'm not speaking from theory. I'm speaking with a reasonable in-depth knowledge of interdisciplinary science. It started somewhere in 2004 when I was in St. John's Medical College, and we ran projects with RV Engineering College. Basically, we would take projects to the engineers and they would do their thesis topics on it. I have successes, I have failures, but I won't burden you with that. We then went on to IIT Madras. We also involved ourselves with the PES Engineering College. I was for a brief while a faculty in their innovation department. When I moved to HCG, I ran programs with Amrita Engineering College. Some of them are still going on, and I think 5 students got their PhDs from Amrita doing projects which we had given them. We also did some nanoscience work with the Jain Institute and towards the fag end of my stay there with Mount Carmel Institute. With CCAMP, we now have programs with Ennapoya, NITTE, JSS, and we are reaching out to Oxford. Hopefully we will have programs running with you also. But these are all ground up programs. I'm not here to beat any trumpets. I'm just saying that the need of the hour is now to work in an interdisciplinary manner. And the more you do it, the better we get at it. And as I said when I spoke to your research committee, our competitors are not in India, our competitors are international. And therefore we need to get our act together. Now, let us talk about the process of innovation, okay? Because the purpose of this talk, and I've been given a humongously long time of 1 hour, So I hope that I don't put you all to sleep. I could speed up and I'd be happy if anybody interrupts me. So let's talk about innovations. Now, innovation starts with identification of a need. Innovation doesn't start de novo in your head that one day I want to create an equipment to raise up elephants into the air. No, you see a need and you create something to satisfy that need. It is usually something which has to be felt and felt acutely. It has to be something which does not have a solution, so you call it an unmet need. This need may be obvious, may be proven, or conversely unidentified previously. Like you may not know you need something to scratch your back, but the moment you feel the need, you invent something to scratch your back. It may be identified intuitively or mathematically, but there has to be a need. Now, what kind of needs? One could be that your senses are limited. That is, I can't see well, therefore I need to invent spectacles. I can't hear well, so I need to invent hearing aids or cochlear implants. I can't walk, so I need an exoskeleton. I can't write, so I need a writing assist. I can't cut my nails freely because I'm an old man, so I need a modification to help me cut my nails, and so on. So, wherever my limitations of doing come into being, things can be made to help me. I tend to fatigue, so I automate things. I can't treat you at a distance, and so you create this telehealth device. I am sleepy and I don't know if the patient has suddenly collapsed. Therefore, we have alarms. So I'm trying to underline the fact that there is a need and there is an invention or an innovation if it is original. So, briefly, what does an innovator do? He enhances human limitations of afferents, that means inputs and outputs, of concentration, of fallibility, of distance, of standardization, of ability to cope with numbers, of ability to cope with tech. This list can go on and on. So, quick recap. I have underlined to you that an idea per se does not qualify for innovation. And innovation per se does not succeed unless, like an entrepreneur, you take it on to market. The second point I've tried to emphasize is that we are all doctors if we are in the healing space. Then medical science is not a pure science, it is an applied science. And that therefore every science has implications in medicine. I've tried to show to you that biology and engineering are closely interlinked. And I'm now going to tell you what does an innovator do in this space. I've told you how an innovator identifies needs, but what does he do with it? And this is what he does with it. And you will at first glance realize that the biomedical innovation process is not a simple process. I'm not trying to make it sound much more complicated than it is, but I'm trying to underline the fact that this is not something you can just wander in like you wander into a garden to pluck flowers. You have to be prepared, you have to move systematically. Unfortunately, if you put ego and hubris first, you fail. This is the first lesson we learn in medicine, and the failure hits you in the face. In other sciences, this hitting does not occur because you could make a mistake in an experiment and nothing would go wrong. But the moment you deal with life forms, your mistakes have catastrophic complications. And therefore, I urge anybody who's entering into biomedical innovations, don't take it casually. I attended one of the talks given by some engineer who came from States to one of the engineering colleges, and he was talking, I want you all to have fun. And I left Because if you think that biomedical innovations is about fun, I would strongly recommend look for fun elsewhere. This is not about fun. Enjoy it, yes, but it is not about fun because it is a complicated process. So take it with due seriousness. If I, as a doctor, were to come to you and while treating your mother and say, I'm having fun, you would run away. So take this with due seriousness. Biomedical innovations is something which you can learn to enjoy, but like a professional. Now, the steps in bioinnovations I will just run through briefly, but hopefully with sufficient detail to give you an overview. So, the first is what you call needs identification. So, how do you identify a need? You identify needs by a process which is popularized in Stanford, which is called shadowing. That is, you follow the professional around. Could be a doctor, could be a nurse, could be anybody, but you shadow them. Now, shadowing is not something done casually. Shadowing requires that the patient permits your presence, that you do not interfere, that you maintain decorum, and there are a lot of preconditions for a person to join shadowing. Generally, professions are worried. Professions are very worried if people come in dressed up like they're going for a vacation because there is a decorum which is followed. But one way, therefore, of getting information is by shadowing. The other is obviously if you do some work in the field, you use your own your own knowledge to identify needs, and therefore you could talk to the professional and ask him what is his need. Now, there is a misconception that you and I have ideas. Now, this bit of wisdom we owe to this wonderful gentleman who needs no introduction, that ideas do not come from you, they come to you. What you do with it makes it yours. And I always think that's the most brilliant summary of the ideation process. If you think I have an idea, it's a way of saying it, but it is not true. The idea comes to you. And what makes it even more complicated is if I'm talking to you, you get an idea. Is that idea your idea or my idea? Or did it come in the gap between you and me? And that is why a lot of these intellectual property rights is actually a bit of a game. Trying to stretch things by making it sound like you invented something. It's like Hindi film music. You know, you hear every Hindi film music, you think it's lovely until you find out that somewhere in 1920, the music director had visited Romania and he heard a Romanian folk song. Anyway, I'm not talking about plagiarism, I'm talking about the fact that ideas float in the ether space and come to you. But the second part is more important. It is not the idea, the same idea may have come to 20 people, but what have you done with it? And therefore, the concept of idea, innovation, entrepreneurship. Many of you all will innovate ideas, it will become patents, it will remain in your college, and you will go on and get a job in IPM or whatever and go on with your life. Until one day you see an invention for which you're paying heavy money and you said, this is the same thing I've done. That's because the person took it to the market while you didn't. What do you do with an idea? The second thing you must learn is many heads are always better than one. So you have to discuss in a group. And the essence of a group is trust. Therefore, you must form trustworthy groups. You must form trustworthy groups to discuss. I just hope that this is not a phone call from one of your members. Please send me a WhatsApp message in case you all want to communicate with me. So the group is always more powerful than individuals. This was proven in our liberation struggle in 1986, where Indian soldiers on both sides, where they were organized, succeeded, where they were disorganized, failed. Now, from an idea, you make a thing known as a benchtop prototype. The benchtop prototype need not look good, but it proves that your concept can work. So that is known, therefore, as a proof of concept. Now, I'm just showing you some images of what they call proof of concepts. It's very crude. It's not as perfect as you would like it to happen. That concept needs to be validated. It could be a process validation. It could be a device validation. And then you need to worry about, do I disclose it? Do I share it? Do I get a trademark? Do I get a patent? Am I infringing on others' patents? Am I infringing on others' trademarks? And that's a topic worthy of many, many hours of study. And then you make what is known as a design for test, because the benchtop prototype cannot be taken into a hospital. So you make the next level, that is something which is not perfect, but incorporates all your ideas and can be tested. And then you come to the second secret. The end user or the person who is going to help, say the doctor or the nurse, has to tell you whether it works or it doesn't work. It pains, it doesn't pain, it's uncomfortable, it's not ergonomic, etc. And this feedback which you get is what is known as an iteration. It is known as an iteration because when you come back a second time, that is the iteration. But the feedback loop keeps the iteration going. And therefore, the Brahma Rahasya of group dynamics is to have a quick, fast, iterative loop. If you have a slow iterative loop, say for instance you are interacting with say HCG hospital and you go to HCG hospital once in 6 months, then if you have to get any input from the doctors, you get an input only after 6 months. And therefore you will change it and go again after 6 months. 1 year of your course is over and you had only 2 changes. While in reality, the changes which are needed are many, many. Therefore, the quicker the iteration, the faster the change. Once you have gone through this, you made the design for test, you make it better, more useful, and you can do more and more testing in greater and greater numbers. And that's the time when you have to start worrying about a clinical trial. Because to prove that your product actually works, you need it to have tested on patients. Now again, the process of clinical trials is one which is fraught with a lot of pitfalls because it's a quasi-legal procedure. Like if you had some device which has electricity running through it and it's not properly grounded and the patient were to get a shock, you would then find yourself in court and you would regret having entered this field altogether. So there are requirements for clinical trial. This area is actually relatively unaddressed in India because clinical trials for drugs are reasonably well established. Clinical trials for medical procedures are reasonably well established, but clinical trials for bioinnovations has not been addressed properly. We are in the process of setting up an ethical board which is independent, which is focused on biomedical innovations, but that as we interact, I'll be able to talk to your faculty better on this. So this is the Institution Ethical Review Board. It's not only ethics, there are a lot of other people involved, they're lay people, they're legal experts, they're scientific experts, and everything which you bring into contact with patients has to go through this, and until you're faced in IERB, you don't know how difficult it is. And then you come to the design for manufacture. So if you make a design for manufacture, you will find it something which has almost no resemblance to your prototype because it is incredibly complex as I've tried to show here. But the design for manufacture is the time at which you start looking at unit economics, how much is going to cost, etc., etc. So then you enter the next phase altogether, which is not the topic of my um, speech, but roughly it is how do you enter the market. Now, to enter the market, you require a knowledge of many things, something about import, export, finances, debt funding, equity funding, etc. A lot goes into it, which is not traditionally part of our teaching. Don't be under any illusion, it is very advanced rocket science, it is all doable. But most of us are not incentivized to go into this because we have enough on our plate. But this can form a critical part of whether your project works or doesn't. Now, am I speaking all this from theory? No. I have been involved with many startup space, and if you'll permit me, I'll summarize it. Now, what I've done in the startup space includes some success and a bit more failures than successes. So, though I mentor many, these are a few I select, which one, they are mainly things where I was a founder. So, I have one which is a success story in the medtech space, which is Cyclops Medtech, and I have some presentations I can show you. I'm involved in one project which is in the speech space, artificial speech space, which is almost reached the design for manufacture level. I have two projects which we started, spent a lot of time, lovely ideas on the verge of kicking off when it broke down due to the fact that the founders started having incompatibility issues. And therefore, I am convinced that a lot of the success of a startup is not in the idea, not in its feasibility or workability, but in the creation of the correct team. Everything helps, but the team is critical. So I have practical experience in this space, so I'm not speaking from theory. Everything that I talked about, I could actually defend. I'm open to questions. I can talk about what I'm doing, biomedical innovations in the C camp, but I think I wouldn't now. I would actually just give you a brief heads up on what Cyclops MedTech has done. I'll leave it open to questions. And, if you're able to work out an arrangement with the Oxford Innovation Program, I would give you a more detailed talk on the innovations program. Let me just see if I can come out and give you a brief update. Just a minute.
Thank you, sir. Participants, if you have any queries, please post it in the chat box or you can
Just
unmute yourself and talk.
Okay, just give me a minute. Let me just tell you a few more things if I can get those slides opened up. Yes, I can.
Yes, sir.
Yeah. Can you see my screen?
Yes, sir.
Yeah, okay. So are you hearing a sound?
Sound we are hearing, but we
Yeah,
couldn't
okay,
see
no.
any videos.
Okay, no, there's not video. No, that was another video which I was trying to play. It started playing now. Okay, so basically the startups. Sorry. Okay, sorry. Yeah. Actually, this is an animation I was trying to show, which didn't open up, showing that the human DNA is working like a machine. I don't know if you all have seen this animation, but I strongly recommend you look at this. You'll find it under, if you put in the search word DNA animations. This is actually an animation of real time, what is happening inside each of your trillions of cells in the body. So this was actually the point I was making, that the human body is the most perfect example of engineering. Okay, I apologize for this disjointed thing. Let me come back to my uh, startup. I apologize again. So what I deal with, or what we deal with, is actually basically eye tracking for health, and we have a company called Cyclops MedTech, and we are now addressing the issue of dizziness using non-invasive, accurate, affordable oculomotor and oculovestibular pathway analysis. And we have a lot of parallel devices which have developed with it. We have about 350 installations and counting. We are now touching 400. We've got generally about every award which is available in the country, and we have got European certification for most. And this is our team, and I underline the fact that this is not a one-man show. So we have an entrepreneur, two doctors, one engineer who's worked for the Pentagon, another engineer based in States who's an expert of AI and ML. So it's taken all of us, and we are reasonably senior in this field, a lot of effort to get uh, a project off the ground. We have raised 2 rounds of funding, and we were able to get in the market in major hospitals, both in India and a few centers abroad, which will now grow with our European certification. So this is a summary of where I am and the messages I like to give students and people who are new entries in this field. I hope I can. I hope I'm open to questions if anybody wants to.
Yes, sir. Participants, you people can unmute yourself and you can have a conversation with sir, or you can post your questions in the chat box.
Have I put them successfully to sleep?
Sir, this is Rita Sharan.
Yep.
Yeah. So bio innovation
Yep.
is a thing, biomedical healthcare. So where we are from the engineering side
Yep.
supporting, means in device level, and someone is doing invention in the drug, molecular biology, and that. So
Yep.
what is your thinking that our side will also be getting credit for the innovation more, or that side? Because
No,
this
I
is
don't. I don't
biomedical
think.
bio,
No, I
that's
don't.
why.
I don't think that. I mean, if you heard my talk, the first myth I busted was that there are any divisions. Let me underline this. There is a student from RV College who is now a faculty in Stanford, and I know him well. He is actually a faculty in Stanford Medical College. He's an engineering student from RV. And this is because the knowledge which he has was actually on medical imaging. But see, it's easy today. If I mean, for instance, in this group, one of the doctors, the other doctor, uh, commenced a course in artificial intelligence with 200 engineers, and he stood first in that course. So this label of doctor and engineer and all this stuff is something you should quickly get rid of. You should look at the end product, the end user, and you should build up your expertise. Because you say, I'm an engineer, I can't touch the patient. Or the doctor says, I'm a doctor, I can't touch anything which is engineering. It just won't work. So you have to learn what it takes to get there. So, I'm just breaking down your fear. Firstly, do not think of yourself as only an engineer. You're a scientist, you got an engineering qualification. So if you have an idea, you could have a medical idea. And if you got come to me and say, I have this idea that if you want to treat a patient sitting here, I can make an RF device so that he can be examined right at the doorstep. And in Corona times, it will be helpful. Now, for me, it is just a question of using your device. If you think that a biology person who has done biotech is better suited for drugs, true and not true, because even the drug making machines are pure engineering. So there is need for cross-cultural understanding, cross-specialization understanding. I'm not asking you to do a biotech degree, but you do read up biotech if you're making a biotech product. You stick to your field, but you should be able to understand everything about it. Simple rule, if you are building a house, you better read up something about house construction, otherwise you'll be taken for a ride. But if you do know something about house construction, you're able to get much more out of your builder. For that matter, cars. So for everything, you need to know the other field. And credit is something which, nowadays cash and credit go together. Nobody's really bothered. I mean, nobody wants to say, be thrilled by saying it is my invention. The days of uh, Tim Cook and Steve Jobs and all that, they had gone even in their time. Steve Jobs himself would have had one idea somewhere early on in his life. The rest was all his thousands of engineers whom he had applied. So, I mean, do you think Sundar Pichai does any work? No. He's only managing the inventions. So, I think you have as much scope as anybody else. It just depends what your product. Leave that credit thing aside. Make the product work. You all will benefit. I hope I make sense.
Yes, sir. Thank you. Thank you.
Thank you, sir. So, on behalf of the management, principals, staffs, and students of the Department of Biotechnology, the Oxford College of Engineering, I extend you a heartfelt gratitude for accepting our invitation behind your busy schedule and giving us such an excellent talk and taking deep into this biomedical innovations in India perspective. Thank you so much, sir, for your wonderful lecture.
Thank you. Thank you very
Thank
much.
you, sir.
It's been an honor.
Thank you, sir. Thank you so much. Dear participants, with the kind consent of the convener, we are officially closing the session 4 of day 3 FD-STTP. So the feedback link is being posted in the chat box. You can fill the feedback and it will be open for the next 10 minutes. Sir, you may kindly sign off.
colleges we had hardware, and before that we had 10 years hardware, and before that we had biomedical.